Hello, dear students. Hope you are doing well. Today, it's our lecture number 2 on Python series, and in this lecture, we are going to learn about modules, pip, and operators in Python. So, in this lecture, you will learn about what are modules in Python, what is a pip, that's a Python package manager, and third you will learn about REPL, and fourth we will learn about operators in Python. So first of all, let we discuss about what is a module. A module is a Python file. You should note it down. A module is a Python file containing reusable functions, classes, or variables which can be imported and used in our programs. So what is a module? Basically, it's a file that contains various functionalities, that contains various reusable functions, classes, or variables which we can import using the keyword import, and we can use the functions of the module. So here we have three types of modules. Actually, these are two types of modules, and we will brief it about here. First is built-in modules, those packages that are automatically installed once a Python is installed in your system. Those are known as built-in modules, just like math, OS, or sys. These are built-in modules. These get automatically installed once you install Python in your system. And second and third, these come under external modules. These come under external modules. So once you install Python, these third-party modules or user-defined modules are not automatically installed. We have to install them. User-defined modules, let me talk about user-defined modules. User-defined modules are those modules that are defined by a user. Just like I will create a module, and in that I will write a function, mathematical functions, like it calculates absolute value, it calculates square root of a number, it calculates cube root, just like that. So those functions that are defined by me in a module, those are known as user defined modules. And the third one is third party modules, those modules that are already built by someone else, and we install them using pip. Those third party modules are installed using pip. So let me talk about first. We have a built-in module. How we import a built-in module? You have to use the keyword import. You have to use keyword import OS here, and once you use import OS here, the module OS is automatically imported in your program, and you can use all the functionalities. Just like there is a function listdir, dir, it what it does, listdir, it lists all the files in your directory. So you don't have to write a separate function for this, it's already written there, and it comes under built-in module. Similarly, we have a function here, math.square root of 25. What it does, math is basically here a module, and square root is a function of module, and what it calculates, it calculates the square root of a number. I will show you through this my program. Let me first create a file in Python. I will name it as module.py. Once I have created a file, I will simply write here print, just like learning modules in Python. I will run my program. You can see I will zoom this, and here you can see the learning modules in Python is printed. Now first of all, what we have to do, I will import module. How can I import a module? I will use the keyword import. I will use here import OS. What it will do, it will import the module, namely OS. Now I want to list all the files in my folder. My folder is here lecture 2. I will write here print. I will use the module OS dot, it's a function. here dot list dir. What it will do, it will list all the directories in my folder. So here this is my lecture 2 folder, and here you can see there are 3 files. Once I execute this program, you can check here that I am getting an array here, and in this array it is showing me all the 3 files that are installed, that are present in my folder. Similarly, I have given you an example of math library. I will import the module math here. Once I import math here, I will write here print math. Since math is a module, I will write here math dot, what I have to calculate, square root, sqrt, square root of, for example, 25. And once you execute this program, you can check here the answer you get, it is 5. Similarly, if I write here 4, what is the square root of 4, and this will give me the answer 2. So instead of writing a program that calculates the square root of a number, this math module automatically provides you all the functionalities that are required by you in for doing mathematical calculations. Similarly, if you want to calculate the square root of a number, you square root, not square root, if you want to calculate the factorial of a number, you just simply write here factorial function and give the number here, just like I give here 5. So it will calculate the factorial of 5, that is 120. I can also write it like this: a is equal to 6, and here I will pass this a in this function, and once I execute this, you can see the answer comes 720. So all the mathematics related functions are present in math module. Similarly, all the OS related functions are present in this OS module. So I will show you another other list of functions here you can use. Just like you can see, here are square root, there are many functions here that you can use. So these are the functions of math module. Okay, I will close it. Math dot close it, factorial of a, I will execute this, and this gives me the answer 720. So these modules are automatically installed once you install Python in your system. Now there comes another topic, that is a user defined module. Suppose I created a new module. It has some other functionalities, just like it calculates the square of a number, it calculates the cube of a number. The code for that module is written by me, that's why it's known as user defined module. And the third one we had, it was third party modules. And for using the third party modules, what you have to do, you have to install them using pip. Now the question arises, what is a pip? A pip is basically a package manager for Python. If you want to install or upgrade or manage your third party apps, third party libraries, for that you can use pip. I will show you the pip here. If I will first clean the screen here, I will type pip list. It will show me all the third party libraries that I have installed, third party modules. Just like I have installed Django here, I have installed Flask here. So the pip list command, what it does, it lists all the packages that you have installed. And if you want to check the version of your pip, you can simply type here pip minus version, and here you can get the version of your pip, and it's 20.2.3. And for example, if I have already installed Flask here, if I have to uninstall it, then what I will do here, I will write pip uninstall Flask, and you can see it tells me, do you want to proceed? I will say yes. The Flask module is automatically uninstalled. And if you can check in pip list, you can see the Flask module is no more now there. And similarly, if you want to install it, you have to simply write pip install Flask, and the Flask module gets automatically installed in your system. So this is how you install or uninstall these third-party modules in your system. I will uninstall it again because I don't have to use it in my program. So coming on to next, if you want to install a specific version of a package, for example, if I write here pip install numpy is equal to 1.21.0, what will it do? It will install the numpy but of version 1.2.21.0. say yes here. You can check here. If I will write, I will copy this, I will paste it. What it will do, it will install numpy of version 1.21.0. so it's installing it like this. So installing numpy, it's installing numpy here. And we will use the pip list command whether this version is installed here or not. It's taking some time here. It has been installed successfully. Now I had told it to install 1.91.0. if I will pip list, you will check the version also here of numpy that is getting installed here. That has checked, it's 1.21.0. now I will uninstall it again because I don't have to use it. Pip uninstall numpy. Similarly, you can upgrade your package, your third-party lab, this module, you can upgrade this also using pip install minus minus upgrade, and you can also use pip uninstall and the name of the package that you want to uninstall, just like we have used it here. And there is also one more thing, that is pip list. It lists all the third-party packages that or third-party modules, I can say, that have been installed in your system. So this was all about the modules. Now there is another concept that is we will discuss about, that is REPL. We will first discuss about REPL. What is a REPL? So if you open your terminal here, cmd, if I open it here, you can see I will type here Python. Now this command prompt will act as a Python calculator. What it will do, it will act as a calculator, it will act as a Python program here. Just like I will write here 2 into 3, it gives me the answer 6. I will write 54 plus 89. If I will use here print, this is a REPL program. So it will, now you can see it works the same as it was working in the Python file. So what REPL here means? REPL here means here read, evaluate, print and loop. What it does, for example, I give two numbers, I give 69 into 85. It will read those numbers and then it will evaluate what the operation I have to perform on that, and then it will print the result, and again it will come in the form of loop. 69 into 85, it has first read those values 69 and 85, then after that it has evaluated them, and after that it has printed the result, and then it comes again in loop. Now in order to close this, what we have to do, we have to write the exit function. I will write here exit, and automatically I will get out of this Python. So RAPL is used for writing, for example, if you have to test a small piece of code, you can check in this RAPL. But once it is closed, the data in it is not saved. And once, just like I have used these functions here, it is not saved in RAPL. That's why most of the time we don't use RAPL, or occasionally we use it. And then there is another topic, that is an operator. I will create a separate file here. I will, no, I have, sorry, I have created a folder. I will create a separate file here. I will name it as operators.py. Operators, sorry, I will rename it here. You can rename a file like this. I will also let me show you once again. If you want to delete a file, you can delete it like this. I have deleted it and the file is deleted. If you want to create a file, you can create it like this, operators.py. So now we are going to learn about operators. What are operators? As you know, the operators are the symbols that perform a specific operation. Now here we have four types of operators. One is the arithmetic operator, another is the comparison operator, and third one is the logical operator, and fourth one is the assignment operator. Now let us discuss them one by one. I will write here, I will create a comment here, working with arithmetic operators. Now what are the arithmetic operators that we have? Those are plus, minus, into, divide. Just like I will write here, a is equal to 20, b is equal to 10. If I will write here print sum is equal to, I will write here a plus b. What does the plus operator do? We have also seen this in the previous lecture, that it calculates the addition. It calculates the addition of two numbers. Similarly, if I want to do subtraction, I will write here print subtraction is equal to a minus b. Now you can see it gives the answer 10. And similarly you can write here, for, you should note this down, I had also told you that for multiplication we don't have any x operator here, but instead we use this asterisk operator, a into b. I will write execute this program and you can see the answer comes 200. And similarly for division, I will write here print a divided by b. What it will do? It will give me the answer 2.0. Now there is another operator that is known as modulus operator. What that calculates? That calculates basically the remainder of two numbers. It calculates the remainder of two numbers. I will firstly comment this out here like this. If the value of a is 20 and value of b is, I will take it 6. Now if I use this print a mod of b, what will it give? It will give me the remainder, and the remainder is the division value comes 3.335 and the remainder here is 2. And also we have another operator here that's known as floor operator. I will tell you how it is different from division. Print a divided by b, it gives me the absolute value. Instead of 3.333, it will give me the absolute value. You can check it here. It gives me the value 3 here. So this was all about the arithmetic operators that we have. And another arithmetic operator we have, that is the exponential operator. I will brief you about that. Just like I have the value of a is 2 and the value of b is 3. I want to do the calculation a raised to power b, that means 2 raised to power 3. For that we have an operator here that is known as exponential operator. I will show you here. Print, I will write here a asterisk asterisk b. You can see what we will get the answer here. The answer here is 8. If I type here 4, it gives me the answer 16. And if I write here 5, 2 raised to power 5, that's equal to 32. So this was about the arithmetic operators, the various operators that are used in our program. We have seen addition, subtraction, multiplication, division, and also modulus operator and floor operator and exponential operator. Now we are going to work with another operator. Those are known as assignment operators. We will discuss about assignment operators. I will write here, I will make a comment here, and I will write assignment operators in Python. Operators in Python. So what are the assignment operators? Just like I will write here s is equal to 50. So what it does, it actually assigns the value of 50 to s. If I print it using s function, I will write the variable here. You can see the answer, it comes 50. Now if I want to increment the value of 50, I can write it by two ways. One way is s is equal to s plus 10. What it will do, it will add the value of s with the value of 10. You can check, the answer comes 60. But instead of that, I have also a shortcut. What I can do here, I will write here s plus is equal to 10. What it does, it basically adds the value. It does the same function add as I had written in the previous statement, but that in a shortcut way. Now if I execute this program, it will give me the answer 60. Now if I write here 20, what will be the answer? It will be 70. Similarly, if you want to subtract a value, if I want to subtract 20 from if I want to subtract 20 from 50, then I will write s minus is equal to 20, and you can see the answer comes 30. Similarly, if you want to do multiplication of s with 10, I can write here s into is equal to 20. You can see this, the answer comes 1000. Similarly, if you want the division, you can write it here like this, s divided by is equal to, and it will give me the answer 2.5. And similarly, you can use the exponential here, s raised power 20, and you can see how much big number this comes here. So this was about assignment operators. We have seen is equal to, plus is equal to, minus is equal to. Now we have another that is known as comparison operators. We will learn about comparison operators. Comparison operators basically give you a boolean value, whether a value evaluates to either true or it evaluates to false, like this. I will write first comment here, hash comparison operators. So if I write here a is equal to 5 greater than 2, I will print the value of a, print a. You can check here, once I execute this program, it gives me the answer, since a is greater than since 5 is greater than 2. Now if I write here 5 is greater than 10, it will evaluate to false, because 5 is not greater than 10. So the comparison operators that we have, that are greater than, equal to, for example, if I will use here greater than, equal to, is 10 greater than or equal to 10, so it evaluates to true. If I will write is 11 greater than or equal to 10, it evaluates also to true. Similarly, just like we have greater than and greater than, equal to, in the similar way we have less than and less than, equal to. I will write here less than. Is 11 less than 10? No, it's not, so it will evaluate to false. If I will write here is 11 less than 100, it will evaluate to true, since 11 is less than 100. Similarly, you can use here less than or equal to. 11 is less than, or I will type here 100 is less than or equal to 100. This evaluates to true. If I will write 99 is less than or equal to 100, this will also evaluate to true. Now we have also, this was about less than, equal to, and greater than equal to. Now we have another thing that is about equal to or not equal to. Suppose I have two values. If a is equal to, for example, 30, b is equal to 50, I want to compare them. Is a equal to 50? Is a equal to b? Is the value of a equal to the value of b? No, it's not. It will evaluate to false. Now if I set the value of a to 50, you can check, since a and b are same, it will evaluate to true. Similarly, if I have to tell that a is not equal to b, for that we use this operator, not operator here. A is not equal to b. What it will do? Is a and b not equal to? This will evaluate to false, since a is not equal to b. Now if I set here the value of 60, now at this time the value of a is 60, the value of b is 50. So what it will evaluate to? It will evaluate to true now. So these are about comparison operators. So we have learned about arithmetic operators, we have learned about comparison operators, we have learned about assignment operators. Now there are logical operators. Logical operators are and, or, and not. What does and mean? And means that both the conditions should be fulfilled. Or means either of the conditions, if fulfilled, then it's okay. And not means the reverse of the value. I will show you this through an example. I will write here, I will comment this my code. I will write here logical operators. So if I set the value of a equal to the boolean true and b equal to the value of boolean equal to false. Now if I print a and b, now you can check here, the value evaluates to false, because for an and condition to be true, both the values should be true. If I set the value of b equal to true, then you can see the answer comes to true. Similarly, if I write instead of and, I will write or here. In or, the condition evaluates to true if either of the value is true. If I set the value of b to false, and here if I execute this program, it will evaluate to true. Now if both the conditions are false, it will evaluate to false, because in an or condition either of the value should be true, only one. Similarly, we have another operator here, that is not. What a not does, it actually inverts the value of a variable. If it is true, it will evaluate to false. If it's false, it will evaluate to true. Just like I will write here not of a. What is the value of a? It's false. It will do its invert. That means it will give us the value. You can check here, it will give the value true. Now if I set the value of not a to true, it will now evaluate to false. You can check it from here. So this was about boolean variables. Now I will show you the same example on numbers. For example, the value of a is 10. I will write here a is greater than 5 and a is less than 9. Here you can check both the conditions should be fulfilled so that the value evaluates to true. What is the value of a? The value of a is 10. 10 is greater than 5. Yes, the condition is true. But here a, what is the value of a? Is 10 less than 9? No. So that this will evaluate to false. So if I execute this program, it will evaluate to false. Now if I write here instead of 9, if I write here 11, now both the conditions are fulfilled. A, the value of a is, I will delete this b here first. The value of a here is 10. Is 10 greater than 5? Yes. Is 10 less than 11? Yes. Both the conditions are fulfilled. Now the value evaluates to true. Now you can, if I now I will show you the use of or operator. If I write here a is less than 9, I will write here or. So if I execute this program, it will evaluate to true, because since a is greater than 5, one condition evaluates to true, the other condition evaluates to false. In or condition, as you know, in or case, either of the value should be true. Now if I write here a is equal to 2, since a is equal to 2, what will the value I get? 2 is greater than 5? No. 2 is less than 9? It will evaluate to true. So this was about logical operators that we have learned about. So far we have discussed about arithmetic operators, we have discussed about assignment operators, we have discussed about comparison, and we have discussed about logical operators. Now I will tell you another functionality here, that is the bool functionality. I will show you like this: a is equal to true or a is equal to 50. Print. What it bool function does, it evaluates a value either to true or a false. Since it holds an integer value, a is equal to 50, this will evaluate to true. You can check here, it evaluates to true. Now if I write here, we remember I also discussed it in data types that we have integer, we have float data type, we have string data type, we have boolean data type, and also we have a none data type here. None means nothing. If I write here none, what does it mean? It means nothing. You can check here, once I execute this program, it evaluates to false. Now if I give this a any value of any data type, for example 13.5, it will evaluate to true. Similarly, if I give it a name hello, I will execute this program, this will also evaluate to true. Now if I write it like this, you can check here, it evaluates to false. And similarly, if I write here a is equal to 0, you can check also here, it also evaluates to false. So by bool you can check whether a value of a variable is an empty or it's none or not using bool operator. Similarly, if I write here like this, we will learn about the lists, we will learn about sets, we will learn about tuples, we will learn about dictionaries in another lecture. But let me tell you, if I write it like this in the form of a list, it will also throw in, it will also say that it's false. If similarly, if I write like this syntax is used for creating a dictionary, it will also evaluate to, since it's empty. For empty things, it will always return false. You can check also this is for using the declaration of a set. You can check here, and it also evaluates to false. So this was our topic regarding the operators and the use of bool operator that we have used. So far we have discussed using bool and modules. What are modules? Modules help in organizing and reusing Python code. Pip is used to install and manage third party Python package, and operators are used to perform operations on variables and values. So let me revise you first. We started our program with modules, and in the modules what we discussed, I told you that it is basically a Python file. It is a package that contains various reusable functions, classes or variables that you can import using the import keyword and using your programs. We have three types of modules. One is the built-in module that is automatically installed once you install Python in your system. Second, we have user-defined modules, those modules that are defined by a user, and third-party modules that are installed via pip. And we saw also how to import an inbuilt module using the keyword import and we also saw various functions. This was about creating a user defined module, and third one was installing the various third party modules using the pip manager, where we checked the version also, where I showed you how to install using the keyword pip install, and for installing a specific version, how you will use it, and for upgrading, and for uninstalling, and for listing all the packages in your program. And after that we saw about operators in Python: arithmetic operators, plus, minus, into, divide, modulus, exponential, floor operator. I told you about comparison operators: is equal to, not is equal to, greater than, less than, greater than equal to, or less than equal to. Also about logical operators: and, or not. Assignment operators: plus is equal to, minus is equal to, star is equal to, and also exponential also. And also I showed you how to use the RAPL. RAPL stands for first read, then evaluate, then print, and then loop. And also I showed you the bool function, which shows us whether a variable contains any value of or not. If it doesn't contain any value, it evaluates to false, otherwise it always evaluates to true. So this was about the modules, this was about the pip, this was about the operators. Now in our lecture number 3rd, we are going to learn about the strings. We are the name of the lecture will be working with strings, where we will learn more about strings, the various functions that we are going to use in strings, the various slicing methods that we are going to use in our strings. And that will be our lecture number third. Hope you understood this lecture very well. Thank you very much.